Good afternoon and welcome to Statistics Part 2. So we will be covering the 2021 exams here. We had our session yesterday where we looked at some multiple choice. Today we'll be looking at ostensibly the short answers, but more important, how to study, how to prep for the 2021 APs. So I am Dr. H, and today I have my favorite moderator with me, Shadna. She's the one who is monitoring your chat. And if you have questions, just put them in the chat and she will forward them to me. So there'll be a short delay, but Shadna is so good that there will not be much of a delay. And of course, our guru who has made all of this possible, Brian, without whose help, none of this would have happened. So on tap today, what are we going to talk about? Well, the 2021 AP testing, how to prepare for statistics, and where we, Princeton Review, can actually help you prep for your APs. So I did want to talk about today the differences between the paper and the digital. So as far as the paper test is concerned, the paper and pencil test, it is on May 17th at noon local time and May 25th. And this will be offered only in your school. The digital version is on June 10th. And to make sure that everybody has it at the same time, it is at 4 p.m. Eastern Daylight, depending on the decision that your school makes. You might be taking it at school, in the computer lab at school, or at home. So that is something you'll have to find out from your school's AP coordinator. Your counselor would be a good place to start. So yesterday I showed you this. This is a breakdown of the traditional paper and pencil test, 40 multiple choice, 90 minutes, and then you got 6 questions, 5 short response, and one long response question. So that's sort of the percent breakdown for the second part of 90 minutes. On the digital version, what you have is you still have this piece is the same. You still have 40 multiple choice questions, 50% of your grade, 90 minutes. It is on section 2 that you actually see the changes. So the long response section is still there, and it's still worth the same as far as the overall grade of the exam goes. What is different is that you have fewer shorter response questions and more multiple choice questions is basically what has happened. So your short response questions are worth the same grade as each other. And the multiple choice, you have 11 more multiple choice for 25 minutes. Okay, so salient differences between the tests is that on the paper, you have 40 multiple choice, on the digital 51. You have more short response questions on the paper, fewer short response questions on the digital, and the long response is about the same. Now, for all parts of the AP statistics, you are allowed a calculator. It is strongly recommended that you take a calculator. They say you can bring in a graphing calculator, but make sure your calculator can do statistical functions. So, if you very quickly need to find the mean, not the mean, the standard deviation, that if you punch the numbers in quickly, it can do that. The major differences between 2020 and 2021, these are the major differences in the digital. As you know, last year everything was digital, is this time you will need to use a laptop or a desktop, no smartphone or tablet. Handwritten or photographed work will not be accepted. All responses go through your keyboard. There is no out of order answering of questions. So these multiple choice questions that you will be seeing, on the digital version, you will see them one at a time, and you will see the next one only after you answer the multiple choice question. As far as the short response and the long response questions, within a question, you can move to different parts. But once you answer the last part of that, either short response or long response, it moves to the next question, and you can't go back. So Um, Watch out for that as you are looking at some of these short response and long response questions. One of the things that you needed last year is you needed a continuous internet connection. You don't need one. It doesn't have to be continuous this time. You need an internet connection at the start of the test. You need one when the test ends. And if in between you lose your internet connection, things will not crash. The other difference is that you can't leave during the 20-minute break. You got to be on camera the whole time. You need to check in 30 minutes before the start of the test. You had to do that last year as well. And the software has changed. So you will have to download new software for 2021. Okay, the old one from last year uh, will not work this time. Okay, as far as what is covered, this is what is covered. This is the same list of topics that has been covered traditionally in AP. So essentially, what that means is it means that in 2020 they took away units 8 and 9 is what they did, and they tested everything else. Uh, but they have this time around they're testing the full syllabus, so all of these 9 units will be covered. And as you can tell, the units that they took out last year, there were low percentage units anyway. The big parts of statistics is really data collection. Okay, of course, probability and probability distribution, and then inference. How do you actually draw statistical conclusions? What do those mean? So these are basically the bigger areas of statistics that you need to worry about. Yes, this is a big portion of it, but most people find this part to be relatively straightforward. So that's why I was looking at these as the areas of focus. So now let's take a look at prepping for the AP statistics. And I'm going to start with an example question. So here, Dr. H takes a 5-day vacation to a place where the probability of rain on any given day is a half. Assuming a day is classified as either a day of sunshine or a day of rain, what is the probability that Dr. H will get exactly 2 days of rain during his vacation? Okay, so the way you approach this is that, of course, you know that the probability of rain, rain, sunshine, sunshine, sunshine is 1/2 to the 5th power. 1/2 times 1/2 times 1/2 times 1/2 times 1/2. And you may be able to do something a lot more sophisticated than this as well. So if the probability of rain were 1/3, you'd say it's 1/3 times 1/3. Probability of sunshine then is 2/3, 2/3, 2/3, 2/3. That's what you'd be doing. Um, But what we want is it could be this setup as well. So really the question you're asking is we have 5 days. I want exactly 2 days of rain. What am I going to get? That's a combination question. So now what you do is you look at how many of these are there, right? 5 slots. How many vacation days are 2 rainy days? So that would be combination 5-2. Okay, so that's combination 5-2. There are 10 such combinations. You can list them out if you want, but on the test, you don't have time for that. You have to trust your formula that it will be 10. Okay, so now what you're doing is you're saying, okay, I have 10 of these 1/2 to the 5th power. So my probability is just 2 days of rain is this 1/2 to the 5th power, which gives me 31.3%, about 1 in 3 chance. Whoops, sorry. Uh, about a 1 in 3 chance for exactly 2 days of rain. Okay, so what happens? This is the concept you learned in school, straightforward. What happens on the AP? Well, on the AP, they actually say, now they give me a 15-day vacation. Yay, me. Maybe I deserve that. I don't know. There might be others. I'm sure Brian and Shadna, who are here, would deserve this a lot more than I would. So maybe I should have said they take a 15-day vacation apiece. So now the probability of rain is a quarter. It's not 50-50 again. and it's the same classification. What they are doing is they're finding what is the mean day, what are the mean days of sunshine. Mean days of sunshine, we know, is the probability of sunshine. Uh, uh, the probability of sunshine, which is 1 minus the probability of rain, which is 3/4. And then the number of days times the probability gives us the mean number of days. Okay, so here it's 11.25 days. This is a relatively straightforward formula, but what you see now is we are being pushed from a binomial model to a Gaussian, a normal curve model, okay, a normal distribution model. The next question is standard deviation of the days of sunshine. So we are making that assumption, and they haven't even told you that they're making that assumption. Okay, so you use the formula again, and you figure out that there are 1.68. That's your standard deviation from the mean. So now you can actually use your z-scores. They ask, what's the probability of exactly 10 days of sunshine? Okay, so notice that here I used binomial again, uh, because these are exactly 10 days. So that's what you would get. Again, it's combination 1510 days of sunshine to the power of the number of days of sunshine I want, probability of sunshine to the power of sunshine that I want, probability of rain to the number of days of rain that I want, and it comes out to be 16.5. When they ask for exactly or at least 13 days of sunshine, what happens then is now you can use the same thing. Here is the calculation for 13 days of sunshine. Here's a calculation for 14 days of sunshine. And this is the calculation for 15 days of sunshine. Still using the binomial model. Okay. Now, if there are more days than that, now we have to switch over to completely switch over to the to the Gaussian model. So let's do that. Now we see what happens here. You know, I take a temporary assignment to where I like to vacation, and I'm there for 120 days. It rained on 40 of those days, and many decades later, because I am so old, I get another temporary assignment to the same location. This time, instead of chisel and hammer, they give me a laptop. I'm that old. So this time I'm there for 320 days. It rained for 40 days. Now, has the location been affected by the climate change? Well, okay, fine. So maybe when I was there with chisel and hammer, it was coming out of the deep freeze of the ice age. Now, they ask to justify the confidence interval to 5%. Why 5%? That's the standard that they use for statistics all the time, is they use a 5% confidence interval. So how would you do this? At this point, you have to look at z-scores. So let's take a look at z-scores because now the numbers are large. So you construct your null hypothesis that the two means are the same. And so what you do is you look at your pooled estimate for rain. The pooled estimate for rain is the number of days times the probability of rain plus the number of days times the probability of rain divided by the total number of days. Okay, so your estimate of rain is 2/11, which is basically your mean, if you will. After you calculate your mean, now you can look at your z-score. So you are looking at the difference in the means from your two samples, one sample and second sample. So it's 40 days out of 120 for one sample, 40 days out of 320 for the second sample. And notice that what we are using here is the estimate 2/11 times 1 minus 2/11 over 120 for the first and over 320 for the second. So now you can crunch through the numbers and this is what you end up with. So that's your z-score. This z-score means you're 5 standard deviations away. So because your probability is so much less than 0.05, you reject the null hypothesis and you say that the means are statistically different. Okay, so location was probably affected by climate change. That's the conclusion you can say, or at least you can say that something changed. You may not know it may be due to climate change. It may be due to other factors, but something changed. You know the means, at least with a 5% confidence interval, are different. Okay, now why did I go through a binomial distribution like this? The reason I went through a binomial distribution like this is really to show you that in statistics, what happens is that the topics actually blend and merge. We started with binomial distribution. Here we are talking about z-scores and a normal distribution. And on this problem, the first problem that we did was full binomial, and as we went through the successive problems, uh, now on this problem, it is full blown z-score and normal distribution. So that is what happens with stats. The topics are somewhat related and blended. So the example that you will see done in class, the very first textbook example, is an example that gives you sort of I call it like the National Geographic example, because those pictures are beautiful, and those are the archetypal. This is what the way it is, a standard paradigm example. But you don't always get questions like that. So you need to be able to recognize what they are testing when it is not a National Geographic type setup, when it's not a paradigm textbook type setup. So let's take a look at some problems here. So here's one. We have a vegetable oil blend packaged by a food manufacturer, and it consists of a blend of oils, canola and corn oil. The amount of canola oil has a mean of, so typically a nice thing to do is to actually make sure you get what you want. So this is the canola oil, which has a mean of 440 and a standard deviation of 10, while the corn oil has a mean of 4.4410 and a standard deviation of 15. Now, instead of highlighting, what some people like to do is they like to write it down on their paper. That's okay. You can, for example, put down canola. You can say you have a mean of 440 and a standard deviation of 10, while corn, you have a mean of 410 and a standard deviation of 15. So here are the questions that come, and typically with the short questions, you will have 2 parts, 3 parts typically. So here it says determine the probability of the amount of oil in a randomly selected bottle will exceed 900 milliliters. Okay, they move on to say probability of the amount of where corn oil is greater than canola oil, and then what is the probability there are 5 randomly selected bottles, at least one contains more corn oil than canola oil. So let's take a look at these. Here it says we'll look at A first. That's not what I wanted to do. We will look at A first to determine the amount of oil in a randomly selected bottle. So what we will do, this is normal distribution. So we'll look at mean amount in a bottle is basically we add up the means. So that gives us 850. As far as the standard deviations go, of course, uh, we will use independence here. They haven't told us it's independent, but we can make that assumption. Now, if you want to write down that, hey, these are independent, that's okay. At least now you're letting the test grader know that they are independent, and we are now at a standard deviation of 18.03. 0.03, we'll call it. Okay, so now you can take a z-score. So there's my z-score, and you can look at the probability of that z-score. So it's 0.28%. So that is a probability that you will actually have uh, more than 900 milliliters in any blended bottle. Okay, why is this useful? Well, this is what places like uh, the Kellogg company in Battle Creek, Michigan. This is what they look at in their factories: how much frosted flakes are going in, how much dried strawberries are going in your cereal. So they actually have very, very good numbers for what goes in where. Of course, one of their concerns legally is that they're not putting less than what they advertise. So they want to make sure of that, and then they can balance their costs out depending on how the cost of corn versus the cost of dried fruit changes. They might have some leeway of changing their blend as well, although typically they don't. They don't want to, because that means they're changing their production. So here it's determined the probability of the amount of corn oil is greater than the amount of canola oil. So so this is similar to the previous question, but now we need to find the difference between the amounts in oil. So we can do that. A mean of the difference is basically canola minus corn, which is 440 minus 410, which is 30 milliliters. The standard deviation is actually the same as in part A. We can just add the standard deviations just as we did earlier. So now we can find the z-score. Okay, so that's what we want. Now we can find the z-score, which is negative 1.664, and then use the z-table, use our normal distribution table to look up the probability, which is 4.8%. Part C is an interesting one. Part C is an interesting one because you could look at it in terms of, hey, I can figure out if I take a sample of 5 and do something with it, what am I going to get? Well, realize the sample of 5 is a small number, right? So what might be easier to do here, and this is where there are examples, several examples where they say, okay, fine, I'm going to take a sample of, typically it's 20 or 40 out of this. What is the probability I get this, that, and the other? You can look that up. But here I wanted to take a slightly different approach so you could see it as well. And the reason I need to do that is because the sample size is small. So from part B, we know the probability of a randomly selected bottle contains more corn oil than canola is 0.048. Okay, so I can rephrase the question as, if I want at least 1 out of 5 to contain more corn oil than canola oil, I can look for its complement. The complement is basically, I want none of the bottles to have more corn oil. I think this is reversed. No. Uh, yeah, no, more corn oil than canola oil. None of them. So that is the probability I don't want. If that's the probability I don't want, I can figure that out. Okay, I know it is about 78%. Okay, because there are 5 bottles, I do this 5 times. And because this is the probability I don't want, what I end up with, the probability that I'm looking for, is 1 minus this number, which is 21.88%. Okay, so here we are. We went from uh, essentially a Gaussian problem, a normal distribution problem, to now we are looking at something close to a Bayesian statistics problem, or at least could you argue it's binomial? Yeah, I guess you could make that argument, but it's really Bayesian statistics is what we're using here. Okay, so we can actually do that, and you see that kind of blend in these types of questions. There are other questions where they will ask you something like this. Here you have a salmon farmer um, choice of 3 different types of foods, type A, B, and C. These are generic names. 2 different breeds of salmon fish, sockeye and chinook. And the salmon farmers want you to design an experiment. So this is your clue. This is a DOE, design of experiments, where you feed them different types of foods, and the objective is largest salmon by weight. And that's what you're looking for. They provide you with 60 salmon divided equally between the 2 breeds, and you have 10 different tanks in which to raise the salmon. Notice I said up to. Typically, they don't mess around here. If they give you 10 different tanks, you use 10 different tanks, and then they want the results in 10 weeks. So design an appropriate experiment, and is your design single blind, double blind, or neither, and explain. Okay. So the first thing to do is to design an appropriate experiment. So certainly what you want to do is you want to go ahead. So let's take a look at the first part. Uh, you are trying to yield the largest salmon, and you don't know the weight of the salmon. So what you want to do is you want to actually weigh the salmon pre-experiment to ensure that the change in weight is due to the diet and not because of tendency in the random samples. You don't know what the sigma is of these salmon at the beginning of the experiment, and you don't want that to mask. Um, this is one of the areas where they will be looking at in their grading. So if you are designing an appropriate experiment, you want to control as much as you can, or at least know what your random variables are, so you can at least account for them, even if you can't, even if you can't control them. So certainly the weight before and after is an important area that you want to look at. Okay, and then what do? You use randomized block design, divide the breed up into 3 groups of 10 salmon each. Okay, see how they made things easy for you here? So place each group into a different tank and feed one tank with one of the 3 types of foods. So basically, let's say one tank of salmon will have type A feed or type A diet. The other one will have a type B diet, and the third one will have a type C diet. These are, let's say, all the sockeye, and then the Chinook one will have type A, the other one type B, and the third one type C, things like that. So you now have them that way. There isn't a control group because I don't know what kind of food they use normally, so I can't have a control group here. And I'm not going to put the salmon in there and not feed them anything. I have to feed them something, otherwise they're going to die. They'll have. It doesn't make sense uh, to have no salmon there. So in some of these design of experiments, um, a little bit of common sense would be uh, may help you think about, hey, I don't have a control group, or where is my control group? Well, in this case, you're comparing the 3 different types of diets, so there isn't a baseline control that you are using. The baseline control is dead fish, basically, after 10 days if you don't feed them. Okay. So what happens is after 10 weeks, have the evaluators weigh each salmon and report the results. And at that point, you can then run the analysis to see which feed, if any, works best, and if not, then which one would work well for the sockeye, which one would work well for the Chinook, things like that. Or maybe they're all the same, so it doesn't matter. But that's evaluation of the results. Here, what they're asking you to do is they're asking you to plan the experiment. Okay, so is your design single blind, double blind, or neither? The archetypal case for single blind and double blind is, does the patient know what uh, treatment he or she is receiving? Is it a placebo? Is it actually a treatment? Is it treatment A or treatment B? Remember, the salmon don't care. So it's not single blind with respect to the salmon, uh, but the people collecting the data. So The way you would have this as a single blind study is actually to make sure that the evaluators who weigh the salmon don't know what type of food each salmon ate or will eat. Okay, so you want to make sure that the people weighing the salmon don't know that. So that would make it single blind. These are the ones who are collecting the data. These are the ones who would have the most impact on that. To make it a double blind, now this is a little bit harder. To make it double blind, remember it's the doctor who doesn't know um, whether he or she is administering a placebo or which treatment. So at this point, if it's the doctor analogy that we're using, administrating a drug, that's our textbook case. Here it would be those administrating the feed. So if those who are handling the feed, who are tending to the sample, the salmon, if they are unaware of the diet or the type of food each tank of salmon is fed, that would be good too. So if somebody would point out and say, okay, this is week 1 for this tank, week 2 for this tank, things like that, then they don't know what feed would go uh, in which tank. So that is how you can make the study double blind. And as you see, it is harder to make the study double blind. It's easy to make the study single blind. You would have to tag the salmon, um, but okay, fine. So you could tag the salmon, but making the study double blind is a little bit harder. Okay, so I wanted to show you that not only can the subject matter morph as you go through a statistics problem, but even the type of answers can differ. The first one was a little calculation heavy. Here, there were virtually no calculations at all. So now you can play to your strengths as to which type of question you actually prefer. If you're a big thinker type, maybe this type of question is easier for you, and these are the types of questions you like to answer. If you are very detailed oriented, maybe um, maybe the calculation questions are better for you. Okay. Uh, okay. So how do you approach this short response section? What you want to do is you want to scan the questions. There are only 5 at if you're taking the paper test. You can't do that on the uh, on the digital exam. And tomorrow, what I want to do is tomorrow I want to talk about a little bit approaching questions. That's all of them on the digital portion of the exam. I know your choices are limited there. So here you want to scan all 5 questions. You want to rank them as easy, medium, difficult, and you want to start with the easy ones and work your way to the more difficult ones. Okay, you want to complete all parts of the question before moving on. This way, when you're done with a question, you are done. There's no point in going back. You end up second guessing yourself and you end up actually putting in wrong answers. If you've gone through a year of AP stats, you have actually developed some pretty good instincts on stats. Your first instincts are likely to be correct most of the time. So stick to them. Okay, and when you're done with a question, you're done. That's what we talked about just now. Okay, keep in mind that the later parts build on the earlier parts. So it's good to go through these questions in order. However, if you find a later part is easier than an earlier part, then don't be afraid to do the later part first. Okay. If you know that one, you might be better off doing that, working on the parts that are easy for you so that your brain has time then to go ahead and think about these harder parts that you will do a little bit later while you're still thinking about that entire problem. Okay, improvement plan for the next practice test. How are you going to improve? Now, Generally, what happens is that we have improvement plans, or we know where we want to be for at the end of our study. We know we want to get a 4 or a 5. That means we need to do these things right, or not as many things like this, or what have you. Well, that's fine. But while you are prepping for the AP stats, you want to have intermediate plans as well. You want to know that from one practice test to the next practice test, you have actually improved. There are people who will say, well, I can take this many practice tests, 2 a week, 3 a week, something like that. This is a standardized test. On a standardized test, if you want to get a different score on your standardized test, you have to take the test differently. If you don't, you will get the same score. That's why you need an improvement plan for the next practice test. And, give it a good shake to make sure that it is indeed a uh, an improvement plan that will actually give you improvement. So the first thing to do is review your last practice test. Of course, this is a standardized test. A standardized test measures primarily as its leading metric how you do on a standardized test. So use that metric. It's not necessarily a, a gauge of you as a person, how much statistics you know. It's really how you did on the test. And tests tend to be representative. So review your last practice test. What should you be asking for the questions that you got right? Okay, did you fully understand the concept? Are there small gaps? There might be. Now, remember, because there's quite a bit of blending of topics, there may be more than one way to solve a problem. Uh, so if you are concerned about that, reach out to your resources, reach out to your AP stats instructor, or reach out to an AP, a statistical, a statistics instructor to say, hey, uh, this is the way I solved it, which is different from what the answer choice says. Am I on the right track? And they may look at it and say, you are 90% there. You just did this little piece incorrectly. Or, yeah, you actually, your rationale is correct. And so while the answer is close, it's not exactly what they tell you, it will still work. But you need to be able to justify this, that, or the other, whatever that may be. Or they might say, yes, your answer choice is correct if this were a small sample, or if this were a big sample, but you have a different kind of sample, so now you need to make a different set of assumptions. Okay. Did you approach the question in the most efficient manner? Remember, you don't have a whole lot of time for these questions. So efficiency is actually the name of the game. And you saw that in one of the earlier problems where I actually used, when you had the 5 bottles of canola oil and corn oil, you notice that instead of doing a whole slew of other calculations, I just used probability from part B and and went through that problem more efficiently. Uh, at least fewer keystrokes on my calculator, less writing on my page. So that's one of the things you may want to consider. Okay. Remember, ideas connect in statistics. So is this idea, do you see how it connects with other ideas? And do you see all those connections? And it might be hard to see all of those connections. As long as you see most of them, that's okay. And in some cases, it might be difficult to know whether you have all the connections. So as long as you are seeing more connections, you should be okay. Okay, so what do you do with the questions you got wrong? With the questions you got wrong, chances are that you may have to look at the concept, or there may be a piece of a concept that you don't get. So, do you understand the concept. That's really what it is. While I'm going through these slides, by the way, these are the slides to help you improve. So if there are any questions, yes, please post them and I will try and answer them as best as I can. What I'm trying to do is, yes, while I do need example questions to work on, what I want to focus on is how to study for the test. You have content resources, you have a lot of access to content resources. I wanted to provide you resources on how to study specifically for the AP stats, and those resources may be a little bit harder to come to. But even if you have content questions, certainly put them down, and I will be glad to answer them. So as far as what questions you got wrong, do you understand the concept? Generally speaking, most people at this point in time will understand the concept. And you've been doing this for a year, so you will understand the concept. This is the part that may actually cause more issues. Can you recognize the concept in an application? Your textbook gave you sort of the National Geographic version of the application. This is the ideal place to apply uh, the application. Do you now or can you recognize it in a less ideal situation? Um, and where is it that that situation doesn't work anymore? So that's really the question you're trying to answer here. Okay, do you know what equations and methods to use? They give you a formula sheet. Actually, we call it a sheet, but you know it's more than one. Uh, when you look at that formula sheet, can you say these are binomial, these are Gaussian, these are, so you know where to use those equations, not just in not just in their National Geographic context, not just in their textbook example concepts, uh, but also when those concepts get a little bit muddy. You saw in the example of the salmon and the fish, where we were looking at single blind and double blind studies, and they weren't quite a doctor administrating a, a drug or a treatment. This was a little bit different, and they will tell you that uh, if you are looking at a diet for mice or rats, uh, the mice don't care. They will eat what you actually control and give them. They will have to do that. uh, the same thing was true here. The salmon would eat whatever diet you fed them. They had no choice there. Greater control. But the people who are feeding the salmon, they may have a bias as well. They may know enough about an experiment to then bias the results one way or the other. And that's the kind of bias you don't want. They may inadvertently be feeding the salmon a little bit more of type A food than type C food, for instance. Uh, and it may not be a conscientious bias that they might be involved in here. Okay. Do you know when the concept is not applicable? Knowing when to apply a concept is just as important as knowing when not to apply a concept. It is easy, especially in statistics, to use the wrong test and then to have bad results. So that is why you absolutely need somebody uh, who has familiarity with AP stats that you can go to and say, if I have an alternate method, is my method valid? Because if the answer is no, then you need to know why. Not just it's not valid here, but you need to know why such that you don't apply it on the test. Chances of you seeing the same question on the test are slim to none. So what you need to do is while you are reviewing your test, you need to actually review or extract from your review what you can take with you uh, to the test. Okay, so uh, that's what I'm trying to get you to hopefully see. Okay, one of the things you may want to know is how many questions you will attempt. I can give you a test with 100 uh, arithmetic questions on it: addition, subtraction, multiplication, division, and powers, not even square roots. And give you an hour to do that test. Okay. It turns out that you may be able to get 60 to 70% of them right if you are rushing through. But if I tell you that now, it's not that you don't know the content. I mean, you all know how to add, subtract, multiply, divide, and take things to powers. Otherwise, you would not be doing statistics. I mean, you do harder math and statistics than what I'd be giving you here. Um, Really, it's a time crunch, and that's how the stats feels as well, especially the short questions. They are really, it's a marathon. You really have to know how to efficiently use your time. There are some questions that require a lot of time because there's a lot of calculations, a lot of number crunching that has to happen. There are others where you can take shortcuts. So it's not how much time do you spend per question, because some are easy, so you'll be able to get those done quickly. And are you actually being efficient when you are doing those, so that you have the extra time for the other questions? And in some cases, it may be worth your while to say that I will not attempt a question or one part of one question, because that additional time I can use in other parts of the test, and it will actually get me more points. So for the 100 question example that I started with, if you don't have to do 10 of those questions, now your accuracy goes up. Goes up to what? Probably 90%. 90% of 90 is 81. So now you are looking at 81% as a raw score versus 60 to 70%. And at that point, it's, I hope, obvious which one you want. It's the hardest thing for students to understand, that you you want to do less and score more. That's essentially what you're doing. Okay, so if you are looking at your raw score, assume an accuracy for attempted questions. Typically, I assume an accuracy of about 90%. For the questions that I would attempt. If you want to assume an accuracy of about 85%, that's okay. At 80%, that is typically a sign that you may want to go back and review some of the content. That means the content area is a little bit shaky. So, uh, so actually go ahead and look at that and consider what you want to do for the upcoming stats, because it's not that far off. So at this point, what you're trying to do is put in your efforts so you can maximize your score. Okay, and calculate an expected raw score. So how do you prepare effectively for the AP stats? Well, I just went through how to use your test. So if you are going to use that test as a proxy, you want to make sure that it's taken under test conditions. And that's why I have practice under test conditions here. Make sure that you know what the format and the instructions are ahead of time, so you're not wasting time on the test and you are being as efficient as possible, and understand the content that will be tested. As you take the practice tests here, adjust your strategy and review the content as needed. And on the day of the real test, celebrate after the test, whatever your celebration is. That means, go for a nice dinner, uh, you know, uh, my my son actually, after his test, after his APE contest, wanted to go play laser tag. That was his way of saying, okay, I'm done. It was his last test as well, so that was his way of saying, okay, I'm done with my tests for this semester. So whatever it is, however you plan to celebrate, this way, no matter how the test turns out, good or not so good, you actually have something to look forward to. It will actually help you during the test, because then during the test, you can think about, yes, I know this is what I have to look forward to after the test. It really does help you then. Okay, how can we help? We at Princeton Review specialize in how to take the test. Yes, the content is important, but our speciality is how to take the standardized test. And uh, the techniques for the standardized test have been fine tuned for that test, specifically that test. We have tutors and instructors ready to help students with, of course, a changing AP format. And the resources that are available to you are, of course, the live AP streams. This is one of them. And we have one more tomorrow. We had one yesterday. We have one more tomorrow. There is AP scheduled tutoring where you can call this 1-800 number down here, 1-800 to review, or you can visit our website at princereview.com and you can actually ask for I want a tutor for, and chances are, uh, uh, you know, the the uh, uh, the office there will be able to find a tutor for you. There is on-demand tutoring as well, where we have instructors on standby, and when you call, you will be connected to one of them, and they can answer your questions. Now, if it is one, an AP topic, let's say one of the languages, you may not be as lucky here on the on-demand tutoring, but certainly the scheduled tutoring, yes, that will work. And we also have AP cram courses. The cram courses that we have are actually designed to give you a crash course on the content that is covered in AP. So the content that is covered, these are 6-hour courses. I think they are 2 3-hour sessions, and that is what their intent is. That here is the content you will need. Um, they are filling up fast, so if you do want to register for them, yes, you can find more information about them on our website. And it's not just stats; there are other AP topics as well for which cram courses are available. Okay, and we also have our cracking books right here. These cracking books have practice tests in them. Most of them have at least 2 or 3 practice tests in them. Some of them have more. If you look at the chem, it says 7 full-length practice tests. There might be some online as well uh, that are available. Uh, so on the stats, you actually have 3 in the book, and you have 2 that are available online. So you have a total of 5 practice tests that are available to you. So you do have enough practice material, and of course you're going to get practice material from your school as well. So you will have enough practice material to help you with your prep work. Okay, so this is actually my last slide. I will take any questions that you may have. Um, okay, Okay, good. Looks like we're good. So if that is the case, I will see you tomorrow where I will discuss the long question or go through an example of a long question and then go through the strategies for each one of the question types, the multiple choice, the short and the long. And of course, at that point, my focus will be how do you actually do this on the digital test? So you can't move back and forth. You're stuck with the problem you're stuck with. How do you now actually approach that problem? Okay, so uh, as there are no questions, I will see you guys tomorrow. I hope you had fun and I hope you come back.